Okay, yesterday we talked about, or started talking about differential equations. What are differential equations?
Equations that have the original equation and the derivative.
Yes, equations that have derivatives in it, somehow or another. So it's an equation that has a derivative in it. And if you got a chance to look at your homework last night, you were asked to solve the last few of those equations. How did you solve those last few equations? Do y'all remember? Have you had a chance to look at that yet? Okay. Okay, when you get to the last few equations, it says to solve those equations by integrating. So that's what you do. So the question is, how is this different than integrating? Well, it gets different than integrating when you have a differential equation like the one written on the board here. This is a differential equation because it has a derivative and other variables in it. What makes this special is that we've got two variables in there, including the derivative. So how do we solve this? We're going to solve it by a method called separating the variables, which, as you can imagine, means that we're going to separate the variables. We're going to get the y's somewhere and the x's somewhere. So I want to walk through the process of doing this algebraically, and then we're going to work through several of these today. It's really not anything much more challenging than what we were doing before with integration. The difference is sometimes, in some cases, you have to get creative with what your C is or the way you write your C. So when prompted with this equation, I would probably first rewrite it so that it looks more like what standard diffie-q's look like. Now, the next step is what you have to be careful of. When you separate the variables, you have to have y on the left and x on the right. Okay? That's just something you need to commit to memory. So we can't say, okay, we'll get all the y's on the right side because it's easier. And I'll explain why in just a moment. But for right now, let's go at it this way. So if we're going to do this, we will have y, move y to that side. We'll leave 2x over here. We're going to move the dx over here. We're going to treat this naming convention as if it's a fraction. So we're going to have 2x dx on the right side, and we're going to have y dy on the left side. Okay? Now, hopefully you see why now we need the y's on the left side. What if I had chosen to say, okay, I want to leave the 1 over y over here and the 1 over 2x over here. Now, in order to get everything that's got an x in it on the same side, well, that's going to leave me with a 1 over dx over there, isn't it? And then when I bring the dy, it makes it a 1 over dy over here. And what do I do with a 1 over dy? We don't know. There's no way to solve that. So that's the reason I say just get in the habit of putting the y's on the left, and you'll be okay. Well, how are we going to do something with what you see written here? Y dy equals 2x dx. What does it look like we could do? If I just had that right there, that looks like we need to integrate, doesn't it? 2x dx. Well, now, you've been studying math long enough. If we integrate the right side, what sounds logical to do to the left side? If we add 2 to the left, one side, we need to add it to the other side. If we square one side, we need to square the other. So if we take the integral of the left side, we need to take the integral of the right side as well. So that's what we're going to do. And now this should become very familiar. How do I integrate 2x? Well, that's what we just had a test over. We get x squared out of that plus c, right? Because we have to have a c. And I'm going to put a little subscript here, 1, because we're probably going to need a c on the other side too. All right, how do we integrate y dy? Well, now y is a variable here, okay? Y is a this says dy. So think of this this is integrating just like 2x was over here. Think of this as to the first power. So what are we going to get then for it?
Y squared, or 1/2 y squared.
Right, we're going to get y squared over 2, or 1/2 y squared, and that's going to be plus a different c, isn't it? Or it could be a different c. So we just integrated the left side, and why did we know that y was not a constant number? Because it said dy, so y is changing. So we integrate with respect to y on the left, we integrate with respect to x on the right. Now, both of these are just constant numbers, C1 and C2. Now we should be able to treat this like algebra. If we just subtracted this from both sides, could we do that? I mean, algebraically, can we subtract a number from both sides? Yeah. And we're just going to get a different C, aren't we? So I'm saying that to say this. Normally, it's customary to only put a C into the integration on one side or the other. Normally, we'll just write a C on the side that we're integrating with x. So when we integrate y dy, the normal procedure would just be to go from here and say, okay, that's 1/2 y squared equals x squared plus c. Because whether it's a number c or a number c on the right and a number c on the left, is still just a constant of integration. So this would be the normal answer, or the normal step that we would get for our answer there. Okay? Good morning, Mr. Butt. How are we today? Tired. What time did y'all get in this morning, last night?
We got in at like 11.
Okay. All right, well. You haven't missed a whole lot. I think this is a relatively easy week to not be here for the lectures, but we've got them recorded if you need them as well. So this would be a normal solution for this differential equation. 1/2 y squared equals x squared plus c. Now, that might not be, there are various other forms of that. We could also say, okay, this is just algebra. If we multiply everything by 2, we get y squared equals 2x squared plus 2c. But in place of that 2c, that's just a constant number. So we could just change that to a number. So this is in the box could be a solution. This that I just underlined, either of those could be considered solutions to this differential equation. They're really the same thing. All right, that's really confusing so far. It's going to get clearer after we do a few problems. So how do we solve differential equations? Big picture, we separate the variables. We get y on the left, we get x on the right, and we integrate both sides. That's big picture what we do to solve differential equations. Any questions about this one problem here? All right, let's go look at the next problem that we've got there. dy over dx equals 6 minus x. Okay, if we're going to solve this by separating the variables, we need to get everything that has a y in it on the left, everything that has an x in it on the right. So if we're going to multiply both sides by dx, we'll get 6 minus x dx on the right side. That leaves us with just dy on the right side, on the left side. So now, at this point in the game, we need to integrate. Well, what happens on the left side when we integrate dy? Y, yes. We're integrating with respect to y. This is the number 1. What function of y has 1 for the derivative? So it's just y equals. And now integrating 6 minus x dx, we can just use our power rule twice. 6x minus x squared over 2 plus a number c. It would not be wrong to put a plus c on both sides, but just like, here's what you could wind up doing. It's not wrong, but it's not commonplace to do it. Because we could have a c on both sides. It could be totally different numbers, but then since they're both constants, we could subtract minus c1 from both sides, and just turn it into one constant number. So typically, you're going to see me just write y equals 6x minus x squared over 2 plus the number, plus a constant of integration. Because we could break that up into anything that we wanted there. All right? Any questions, comments, observations there? All right, good, good. Almost the same thing. Would you agree? Almost the same thing. But it's going to yield us a dramatically different answer. So when we separate the variables, what are we going to wind up with? All right? dy. Okay, good. I haven't talked about that yet. I'm glad you said that. Okay? In order to integrate, we've got to have something times dy. So we can't just add y to each side, because that would be y plus dy over dx. We don't know what to do with that. So what we've got to do in order to finish this off, is we'll multiply and get 6 minus y times dx. But then we can't integrate that, can we? So we need to figure out how can we move this whole thing to the other side. What do we need to do? Well, if you'll think of it as algebra right now, this quantity is being multiplied by dx. So how do we get rid of it? We divide by 6 minus y. And if we divide the right side by 6 minus y, we need to divide the left side by 6 minus y. So we wind up with some ugly creature like this. 1 over 6 minus y times dy equals dx. Now let that sink in and be sure you see how we got that. And we've got to do that because we've got to have something, think of it as something times dy. Well, once we get to this point, we've got our inner variables separated. We need to integrate. All right, if we integrate the right side, we get x plus c. What do we do on the left side? How do we integrate 1 over 6 minus y? With the denominator being a binomial, we can't do that. And make it to the negative 1 power, and then when we integrate it, what do we get? 6 minus 1 to the 0 power over 0. Right. This is one that we've got to look at and say, this is going to be an ln. So, u is 6 minus y. So that means du is negative dy. We've got to go back and pull out what we did on the last test. We don't have a minus sign up here for our dy, so that becomes negative du equals dy. So now we can substitute in. Whew. We substitute a minus sign in front of integral 1 over u du. Well, now we remember how to integrate 1 over u. It's the absolute value, it's the ln of the absolute value. So we've got minus ln absolute value of u. But we had y's in it to begin with. So we've got minus ln absolute value 6 minus y equals x plus c. That right side was easy to get. That left side was a booger bear. And we look at our multiple guess answers, and that's not a single one of the answers. And none of these is not one of the options. So we've either messed up or we've got to keep going. We haven't messed up, so we've got to keep going here, people. Suggestions? All right, let me give you a suggestion. Let's change this to the ln of 6 minus y equals negative x minus c. What did I do? Multiply by negative 1, okay? None of our multiple guesses have ln in the answer. So how can we undo ln's? E, okay? So we're going to change this into e's now. We've got 6 minus y equals e to this ugly power, e to the negative x minus c. All right? We're getting closer. All right? Now we need to let's see if we can get y by itself. So we've got negative y equals e to the negative x minus c minus 6. Well, let's get rid of that negative sign in front of y. So we get y equals negative e to the negative x minus c plus 6. That's better. And now we can simplify still this piece right here. How can we simplify e to the negative x minus c? All right, let's take a side note over here for a second. If I've got e to the a times e to the b, e to the a times e to the b, how could I write that simpler? E to the a plus b. So we could write it like this. We could say that's the same as e to the negative x times e to the negative c, right? Plus 6. Would y'all agree with that? All right. Now, if we raise e to a constant power, if we raise e to a power, we're going to get a number, right? And would all of you agree that this number right here is going to be, we don't know what the number is, but it's going to be a number because c is a power, e to the negative c. So we can change this, and this is kind of mind-blowing, okay? Minus c e to the negative x plus 6. Now, this c right here is not the same c as that one up there. It's just standing for it's a constant, okay? If it makes your head feel better, you could call this k or call this one up here k. But they're not the same number. It's just a different number. And this is normally the way you're going to see any differential equations written that have e in it. Most of the time, they're going to have a constant in front of them. It'll be c e to a power. This is a process that you need to get accustomed to having to do anytime you've got LNs in it to get rid of it. On the test, on this next test, it will not be all multiple choice. Some of it's going to be show your work. So I might give you this problem and say get to an answer here. When I do that, I'm going to tell you write your answer as y equals. Write your answer as y squared equals. Because if I don't give you that information, you could have stopped right here and said that's the answer. And it is. It's just not in the simplest form that we would normally expect to see it in. So this is the expectation to write y equals negative c e to the negative x plus c. Plus 6, I'm sorry. Wasn't that fun? It gets worse, okay? It gets worse. Let's keep rolling through a little bit and just see what happens here, okay? Not all of them are that bad. Y prime equals the square root of x over 7y. So, first thing I'm going to do is I'm going to rewrite using the dy over dx naming convention. And now I'm going to move the dx over here. And we have a choice to make. Do we want to multiply both sides by y or multiply both sides by 7y? Why do you say 7y? That way we don't have a fraction on the right side. There is no right or wrong answer between those two. You could do either one of them and get there as long as you're consistent. That's exactly what I would do, though. I would make it 7y over here and the square root of x over here. It just makes it look easier to deal with. I don't know if it's going to be easier or not, but it looks easier to deal with. So now that we've got our y's and x's separated, remember we have to have something and think of it as times dy, although that's really not what it's doing, and times dx. Think of it in those terms for right now. And then we've got to integrate both sides. So when we integrate x to the 1/2, we get 2/3 x to the 3/2 plus a c. And over here we get y squared. We get 7 over 2y squared. Whew. That was easy compared to the last one, wasn't it? Well, you could, it depends on what I said. We could say solve for y squared, and you just need to multiply by 2/7. But yes, that's pretty much done right there. That's as simple as we'd want to get there. Yeah, you thought, oh boy.
This is where it gets worse.
By the way, yeah, no, this it's hard to look at problems and tell how easy or hard they are. Okay, so this one is one that's relatively simple. I mean, when we looked at that one, didn't look that hard to begin with, but boy, it winds up to be a lot of algebra to work through. All right, let's keep looking at these. Let's look at another problem here. See what you can do with this problem on your own before I jump in. Y prime equals x times 1 plus y. So separate the variables, integrate both sides, and just stop after you integrate, okay? And we'll discuss, do we think we need to go further or not. That's how I would separate my variables. ln of 1 plus y equals x squared over 2 plus c. Am I going too fast? Everybody see how we got there okay? Now, does your gut say that's a good place to stop? Okay, so what do you think we need to do? Your mind says, please stop, please stop, please stop. I understand that, but your gut says we need to do something now, okay? And that's a good thought there, because we want to make these simple for somebody that's not as smart as we are to solve from here on out. Solving that with a calculator is kind of time-consuming here. We want to be able to get it simpler so we can hand it off to somebody less intelligent, and they can do the grunt work. We've done the hard part here. So I'm going to introduce e's. So we'll have 1 plus y equals e to the x squared over 2 plus c. All that's a power. And now I can move the 1 over. And I'm going to just poof miraculously do this at the same time. C e to the x squared over 2 plus c. How did I poof miraculously pull that C down there?
Because it would be times e to c.
Right. This is the same as e to the x squared over 2 times e to the c. And that e to the c here is just a number, and we're going to call it a capital C there. So y equals c e to the x squared over 2 plus minus 1. Thank you. Minus 1, yes. Sally told me, but didn't tell me there. Her look on her face said, oops. Yes? We wouldn't need a plus C here because, remember, once we integrated, we put the C in. Yeah, and that's something that students get in the habit, or you've gotten it in your mind, when I integrate, I put a C in at the end. Okay? And that's correct. But it's really not the end. It's after you integrate, you put the C in. It just happens to be the end of what you've been doing before now. As soon as we integrate, we need to introduce the C. Okay? So that's where we introduce the plus C, and then it just winds up being in front of the E power here. So this would be the correct answer. This is the expectation of where I would want to see you to get to there. Y equals C e to the x squared over 2 minus 1. And now we can hand it off to somebody else, and they can do the grunt work. Okay. Feeling a little bit better about these as we progress through them a little bit? You don't like them, but you're feeling a little bit better about them. That's fine. All right. Solve by separating variables. What do you see as a problem here? Yeah, we've got an xy plus a y prime. And I wouldn't let Ford do that a while ago when he wanted to do it. So we've got to separate this thing. We want something dy equals something dx. That's our goal to get to. How do you think we need to start manipulating that? Go for it. Very good. We're going to subtract xy from both sides. Good. And then we see our Algebra 1 kicks in. We can factor an x out of that and make it x times 100 minus y. All right? And now that looks a little bit more like what we've been accustomed to dealing with. So now we can simplify this. Whoops. 1 over 100 minus y dy equals x dx. I'm okay once you get to this point with you looking at this on the left side and say, I know that's going to have an ln in the answer. Okay. Now, if you need to do the u equals 100 minus y and du is negative dy and all that to get to the answer, that's fine. Get to the answer. But your goal needs to be to learn to do these as quickly as you can so you don't have to waste a lot of time. So I'm going to look at this and know that needs to be negative ln absolute value of 100 minus y equals x squared over 2 plus c. And you can't leave it there because we don't traditionally leave it with an ln there. So see if you can solve that out for y and get y equals something in the end. y equals c e to the negative x squared over 2 minus 100. Questions? Ask them, because I've got one for you if you don't have one for me.
It'd be, plus 100, because you subtract 100 to go to the right side, and you divide by negative 1.
So we would subtract here, we'd add there. Okay, I'll buy that. Yes, I like that better. Still got a question if you don't have one. Should this c be negative? Should it have a negative sign in front of it? Because it was e. If I'm taking this thing right here, that's e to the negative x squared over 2 times e to the negative c, isn't it? Should it be negative? Say that again? It's a different constant, yes. But should this be a negative number? It's not a negative number. If we take a positive number and raise it to any power, it's going to be a positive number, isn't it? So it's going to make it, yes, it's going to be, this e to the negative c is probably going to be a small number there. So no, it shouldn't be a negative there. Some students sometimes want to think, well, since it was negative up here, it ought to be negative down there. That's not the case. You can just write it as a c. Secondly, it doesn't matter what you write there as far as positive or negative, either one. Because if you write a negative sign in here and had to solve for c, let's say that Sally and Ford both worked this out, and one of them put a positive c there and one of them got a negative c. And then the next step was find out what c was. If Sally finds out that c is a positive 59, Ford's going to find out that it's a negative 59. It's all going to come out in the wash and give you the correct answer there. But it shouldn't be, don't think it should be a negative number just because the power up here was negative. It's not going to be. Because we divide it here, again, it doesn't matter. It's okay to write it there. It's okay to write it there. Technically, yes, you can write it there, but that c is going to counteract it in the end anyway. Negative c e to the negative x squared plus 100 is probably what you'd see as a multiple choice answer there, okay? All right, we're getting close to the end here, I think. Yes, getting real close to the end. All right, this is not a problem to solve as much as it is an equation to, well, we're going to write the equation, then we're going to solve it, okay? The rate of change of n with respect to s. The rate of change of n with respect to s. What does that mean to write down mathematically?
N prime.
N prime, or dn over ds. Why over ds with respect to s? So in that respect, it's better to write dn over ds than n prime, because now we know that we're working with s. Is proportional to 500 minus s. What does that mean? Equal to 500 minus s. And we have what's called a constant of proportionality in there. We don't deal with a lot of proportions, so you may not remember that, but we have some number. We don't know what the number is, but some number is going to be the constant of proportionality there, k. Is that a differential equation? We've got variables and we've got a derivative, so it is. So can we solve this differential equation? dn equals k 500 minus s ds. Do we need to divide both sides by k? It's not necessary, because n is the variable that we're integrating with over there. It's not that. So now it's not wrong to divide by k, it's just going to make your problem a little more challenging to solve here. So now if we integrate, we get n over here. I would probably, Yeah, that's a good thought. I'd bring that K all the way to the outside. Thank you. I went brain dead there for a minute. Now when we integrate 500, we get 500s minus s squared over 2 plus c. Okay? You need to be sure that you remember this is proportional to, gives you that constant of proportionality there. Easy enough to solve? Good, good, good. I think we're going to look at one more. Oh, we got two more problems, but I don't know if we're going to look at both of them. The rate of change of V is proportional to V. Yes, we do need to work through this one here. The rate of change of V is proportional to V. When t equals 0, V is 20,000. When t equals 4, V equals 12,500. What's the value of V when t equals 6? All right, so let's start off with this thing up here. The rate of change of V is proportional to V. What does that tell you? dV over dt equals V, almost, kV, or VK, however you want to think of it. kV, VK. The rate of change of V is proportional to V. So dV over dt equals kV. Why dt? How do I know dt? Because it's time, and it says t equals 0, so that's a good indication there. So now we need to solve that. dV, whoops, it's not going to be over anymore. dt. Now, do we want to divide by V or divide by kV? Does one seem to be easier than the other? I think just dividing by the V is going to be easier. Now we're integrating K over here. We're integrating 1 over V over here. And that just looks easier to me. 1 over V dV equals K dt. So what are we going to get on the left side when we integrate? ln of absolute value of V equals, what do we get over here? KT plus a constant, right? Well, I don't like the LNs, so we're going to E both sides and make V equals E to the KT plus C. That's right. And just like we've done before, when we had a variable plus a constant up here, we can say V equals C E to the KT. Have you seen problems like that? Have you seen equations similar to this before? Where have you seen equations similar to that before? Who can recall? If you've done any personal finance, you've dealt with PE to the RT, PERT formulas. If you've dealt with fruit flies in AP Bio or Bio, you dealt with that, or not anything else, you've dealt with them in those places there. If you've dealt with radial half-lives, does that ring a bell? Carbon dating, all of those things give us that. So there's our solved equation. V equals CE to the KT. Now, we want to know what V is when T is 6. So we've got V equals CE to the KT. How are we going to find out what V is when T equals 6? If I plug 6 in there now, I don't get anything but a bunch of letters. What can we do? Let's go back and use the other information and just see if we can get anywhere. Go for it, Ford.
T equals 0, make V 20,000.
Right. So if we use that first piece of information, 20,000 equals CE to the 0 power. And E to the 0 is 1. All right, so now we can change it. We got V equals 20,000 E to the KT. Well,
12,500 is V, and then 4 for T.
Right. Now we can use this other piece of information right here. When T is 4, so over here on the right side, if I say 20,000 e to the 4k, that's got to be equal to 12,500. Y'all with me there? Cut. And let's go down the page a ways. There's a reason I did that. So we've got that. Now, how on earth are we? Well, that looks like a single equation with a k in it. Can we figure out what k is? How are we going to solve for k? Say what? Yeah, 12.5 divided by 20,000 equals e to the 4k. And now we're going to take the natural log. I'm not going to pick up my calculator yet, but y'all can if you want to. I've got the natural log of 125 over 200. Does everybody understand why I dropped off some zeros there? Just 2 extra zeros out there. The natural log of that equals 4k, because if I take the ln of both sides, the ln and the e kind of cancel each other out. So that k then is this number, ln 125 over 200 divided by 4, which you've got a calculating device and you can figure out what that is. I will tell you, when you're solving these equations, it's very important that you keep a bunch of decimals to get an accurate answer. You're going to find out that k is probably a really small number here, so probably take 3 or 4 places after the decimal. But now that we've got that, I mean, in real ugly terms, we've changed our equation to this. 20,000 equals e to the ln 125 over 200, all divided by 4 times t power, which is very ugly to deal with. But now figuring out what happens when t equals 6 is relatively easy, isn't it? Plug 6 in there and punch in our calculator and we get something. Do you expect V to be bigger or smaller than 20,000? And why? Why?
Because at 0 it's 20,000, and at 4 it's 12,500.
So just initial looking at this information, it dropped from 20,000 to 12.5, so we expect it to be smaller than 20. We expect it to be smaller than 12.5, and I'm assuming you can figure out what that is, okay? All right. Solving DiffyQs is separating variables, y is on the left, x is on the right, and integrating both sides. Don't be afraid to look back at some of these when you get to homework and say, I'm not sure what I was supposed to do. You'll probably find an example like it here. Tomorrow, we're going to talk about some applications of these, and that's where it gets a little bit easier, I think, to deal with there. But we'll talk about applications tomorrow. All right. Thank you very much. The time is yours.